All right, I'm going to show you another example of conceptual problem solving with variables only. This one for the same object but with two separate motions. Now you did problems like this on the first problem set of this unit in kinematics, but we're going to do it now without using anything but variables. So I'm going to show you how you can express this in just variables using breaking down the problem into two different parts and then identifying what's common to the two different motions. So we have a recent race, Dusty Crophopper, and he's flying the first 2/3 of the total distance at a certain speed, and then the last 1/3 of the total distance at twice the initial speed. So I really have all the information, speed information relative to one speed. But what I want is an expression for his average speed relative to his initial speed. So average speed for the total trip. Okay, so let's draw a picture first. A simple picture. And it breaks the trip into 2/3 the total distance and 1/3 the total distance. And this will be the total distance that is from beginning to end here. And we know that Dusty flies at a certain speed. I'm just going to call that speed 1 for the first 2/3 of the trip. And then twice the speed, S2, which is double S1. So right off the bat, I can replace S2 with 2 times S1. So anytime you're doing a conceptual problem, you want to use relationships like that to eliminate a variable. We'll make it simpler. But I want to find an expression for his average speed over the whole trip. Well, we know that average speed is just, for a total trip, is total distance over total time. And I'm not going to use my delta t, I'm just going to use time. We know that time or delta t both refer to over which the period it was operating at a certain speed. So time 1, time 2. Okay? All right, well, what's total time? Well, total time is just going to be equal to my first time plus my second time. So that's another relationship I might use in this formula. Because I know now 2/3 the distance at a certain speed, 1/3 the distance at a certain speed relative to the other speed. If I express these two speeds in terms of time, I could substitute that for my total time by adding the two together and then solve that expression out and see what I end up with. See if I end up with an average speed relative to speed 1. So let's use my speed equation, which is just distance over time, for my two sections of motion, 1/3 d total over time 2, okay? And since I want speed average in terms of speed 1, oh, this is, sorry, 2 times speed 1. So what I want to do is try to combine these formulas. Well, since I know time total is time 1 plus time 2, if I express this in terms of t1 and this in terms of t2, I'm going to have something that has speeds in it and total distances in it. Well, I have a total distance here, so maybe those will cancel. And then I'll have some expression on the right-hand side here in terms of speed 1s that's going to tell me my speed average. And since I want the average speed relative to my initial speed is speed 1, average speed is speed average. If I approach it that way, then I should be able to get some kind of expression. I'm going to see how far I can simplify it. So let's simplify this for T1 and T2. So multiply by T1, divide by S1, multiply by T2, divide by 2S1, divide by 2S1. So I'm left with T1 equals 2/3 dt over S1, which I'm going to rewrite 2 dt over 3S1. And I get here T2 equals, I have 1/3 dt over 2S1, so the 1/3, the third goes to the bottom, so I have 1 just dt over 6 s1. So 1/3 over 2 is 1/6. So now I have an expression for t1 and t2 in terms of dt and s1. So let's substitute these in over here and then simplify it out as far as we can go. So speed average equals dt over, well, t total is t1 plus t2. So I'm going to put in for t1 2/3 dt over s1 plus t2, which is dt over 6s1. And hopefully you can see from this, I can factor out a dt and an s1, a 1 over s1. So let's do that. So let's factor out the variables first. So speed average equals dt over, and a dt over s1 is common, so a dt over s1 times 2/3 plus 1/6. And now I have a dt on the top, a dt on the bottom. The dt's cancel, so I'm left with 1 over s1 times 2/3 plus 1/6. Well, 1 over s1, the s1 goes to the top. So if I rewrite this, I have s1 over 2/3 plus 1/6, which is 5/6. And since 5 over 6 on the denominator, the 6 goes to the top. So I get a final expression of speed average is 6/5 the initial speed. So what I want you to see with that is that I never needed to use numbers. What I used were expressions for the speed during the first part and the second part, an expression for the overall speed, and then combinations of relationships that I know. I know S2 was twice S1, so I eliminated S2, and I know time total was a combination of the two times. And by doing this and combining them and simplifying, I'm able to get an expression for the average speed in terms of only the initial speed. And that's solving a conceptual problem with variables only.